Morning, students. Today we are going to discuss about sequential search. In sequential search, input is an array element and a key, and we have to search whether key element is available or not. So, given an array, it consists of n elements and it starts with 0 to n minus 1. And I'm going to give a key that we call it a search key. And I'm going to search whether the key search key k is available in an array or not. If it is available, then I have to return index of the element of A that matches K, and I have to return -1 in case of failure. So just please go through that algorithm. So you have to start with the keyword algorithm, which should be written in uppercase, then followed by algorithm name and input. Input is an array and a search key. Okay, so this is a thing we are telling whether it is going to search for a given value in a given array by sequential. The problem statement, I have to define it in a command statement. Then I have to mention what is input, what is output. Here only logic started. So in the logic started, I have to search an entire array one by one. Correct? So I have to use a while loop, and I am going to use a counter variable I, and initially you have to make it I is 0. Then I have to check whether that A of I is equal to K. If it is equal to K, then you can stop the process. If it is not equal to K, then increment I. I has to be incremented by 1. And when it comes after the while loop, when it reaches end of list, and in case of failure, it comes out of the while loop. When it comes out of the while loop, again, I have to check for the condition I less than n. I less than n indicates success, and I it's not less than n, it indicates that it reaches the end of list and the item is not available. So in that case, I have to return -1. So now we are going to find what is the time efficiency for the sequential search. Since this algorithm time efficiency depends on both input size and also particular input, here we have to calculate best case, worst case, and average case time efficiency. To calculate time efficiency, the time efficiency you're going to represent as a function of n. What is n? That input size. So we have to find the input size. Here the input size is what? Number of elements in an array is your input size. So that is n. So here we are denoting the variable small n as a number of elements in an array. So small n is input size. Then what is your basic operation? Here many operations are there. What are the operations here? Assignment operation, less than operation, not equal to, again here less than, like that many operations are there. So we are not going to consider all operations. Out of all operations, you have to pick any one operation as an important one and basic operation. Okay, here I am identifying this not equal to as a basic operation because it is the most important operation, right? So I am going to consider this as a basic operation. Then I have to calculate 3 types of efficiency: best case, worst case, and average case efficiency. So what is best case? Best case efficiency is for best case input. So what do you mean by best case input? For that input, it is the time taken for execution is very, very small. So what you can say input size is 5. I'm reading the elements as 1, 2, 3, 4, 5. I'm going to check whether 1 is present or not, but 1 is present in the first location. So this is your best case. So how many comparison is required here? Only one comparison is required. So T of n is 1. So another efficiency is worst case. What is the worst case? That is your case 2. The key doesn't exist or key is available at the last position. That you can consider as a worst case. So what do you mean by worst case time efficiency? It is for worst case input. Here in sequential search, worst case input means, say I'm going to search 5. In this array 1, 2, 3, 4, 5, I'm going to search 5. 5 is available in the last position. Or I'm going to search say 11. The 11 is not available in an array. So in that case also it is going to do n number of comparisons. So that we call it as worst case. So what is worst case? If the element is not available, when we will identify that element is not available, after searching the entire array only we can able to understand that it is not available, right? So number of comparison required is n, right? Next one is average case efficiency. What is the average key efficiency? Is that the search key can be present at any location. For all possible inputs, you have to calculate. Here that you have to find out the probability of success and probability of failure. So if you are going to consider P as a probability of success, then 1 minus p is your probability of failure. So if you're going to consider 1 minus p as failure, number of comparison needed is n. So I'm going to consider the probability of success is p, that the probability that it can be, that the probability that the search key is available in the first position, or the probability that the search key is available in the second position. Any position, the probability is p by n. We are assuming that the probability of first match occurring in the ith position, for every I it is p by n only. The probability is p by n. So suppose if the element is 1, 2, 3, 4, 5, I'm searching 1. So one number of comparison required is 1. Say for example, instead of 1, 2, 3, 4, 5, you can have it as 11, 12, 13, 14, 15. Or you can have 11, 22, something else, right? So if I'm going to search 11, number of comparison record is 1. If I'm going to search 22, number of comparison record is 2. 13 means 3 and so on. So the number of comparison record here, it is 1, 2, I till like this. So you have to write a formula. Then you have to solve it. Then you will come out with this equation. Okay. So if P is equal to 1, that indicates successful search. Here, if you substitute P is equal to 1, so you'll be getting n plus 1 by 2. In case of failure, the time efficiency in n. So like that, you have to calculate the time efficiency of all algorithms. So first you have to identify the basic operation. Then you have to count number of times basic operation gets executed. Suppose if it depends only on input size, one time efficiency is sufficient. If it depends on both input size and particular input, you have to calculate all three efficiency. Thank you. So we can able to discuss one more example, one more case study, how to find the time efficiency for maximum element. So previously we have discussed how to find time efficiency for sequential search. It depends on both input size and particular input. So we have calculated many things. But in case of maximum element time efficiency, this is a logic. So what is the logic? Initially, I'm going to assume the first element is a max and I'm going to compare with the remaining elements, right? So here, say for example, say this is the input, say 10, 1, 4, 7, 77. So here the maximum element is available in the last position. Okay, fine. Here in this case, say 99, 99, 7, 27, 6, 5. So in this case, the maximum element is available in the first position. The maximum element, it can be in any position. According to the logic, it searches the entire array. So the algorithm time efficiency depends only on input size, not on particular input. The logic I'm speaking about. Here the logic is what I'm checking, whether it is greater than that variable max value. Okay, so that we are going to do it for all elements in an array. So it depends only on input size. So one time efficiency is sufficient. So what do you have to do? So many operations are there. Say assignment operator, greater than operator. So out of all operations, I have to pick any one as a basic operation. Here I'm going to pick greater than as a basic operation. Okay, how many times gets executed? Summation I is equal to 1 to n minus 1. So how to solve this? So solve this, one formula is there, that is upper bound minus lower bound plus 1. So this is your upper bound, this is your lower bound. So n minus 1 plus 1. So you'll be getting n minus 1. So as per asymptotic notation, you can able to note it as this one is a theta notation, right? So n minus 1 can be represented like this. So what it indicates that C of n as belongs to theta of n. It means it is said to be theta of n. It is said to be theta of n. Why? C of n is less than or equal to some constant into n, and also C of n is greater than some constant into n. It indicates that. So already we have discussed many asymptotic notations, big O, omega and theta. You can use any one notation for indicating the time efficiency. So n minus 1 is a time efficiency. With the help of this asymptotic notation, you can make use of any notation, big O, omega and theta. Finally, you can write an answer. Thank you.